Thank you for the fire brought us. We ask you as we are going to begin our lesson, may you guide us, may you protect us, give us knowledge, understanding, so that we shall be able to understand what we are going to learn. We ask you to help us maintain our knowledge so that we can use it for the better purpose. In Jesus' name I prayed.
Amen.
Amen.
Thank you so much for that wonderful prayer.
Welcome, teacher.
I believe God has heard our prayer and is going to answer our prayer for sure. I welcome you once again to today's lesson. For those who have just joined, simply call me Teacher Daniel Alira. We'll be discussing, or we are always discussing here some good physics. We're always discussing here some good physics every Friday morning at 9. We discuss some good physics. So that is briefly for those who have just joined today. My name is Teacher Daniel Alira. In my class, that is Senior 3, we always talk, we participate, we contribute, we do whatever we are talking, whatever we can say. And to start on that, may I request somebody who attended the last lesson to raise up the hand. If you attended the last lesson, can you raise up your hand? I will see you. Those who attended the last lesson, please raise up your hand. I want to see you. Those who attended the last lesson, can you raise up the hand? I see Claire has raised up the hand. Yes, Claire, can you unmute? Claire?
We studied about diffraction of waves and refraction of waves.
Very good. What did you say about refraction of waves? Claire? Hello, Claire? Claire? Oh, you have lost Claire. It's okay. Let's pick another person. Hey, Claire, you see there, Claire? Oh, Claire. Oh, it's okay. Who else was present? You tell us. Yes, Marvin?
Yes.
What did you study in the last lesson?
In the last lesson?
Yes.
I didn't attend.
Oh, sorry. Patricia, did you attend? Patricia?
No, I didn't attend.
Oh, sorry. Let me hear from Maria. Maria?
Oh, teacher, we studied.
We describe diffraction of
Maria?
waves as...
I attended, we studied diffraction.
What did you say about refraction?
Diffraction is the spreading of waves as they pass through holes, around corners or edges of an object.
Very good. The spreading of waves as they pass through holes, as they pass through a corner, or as they pass through what they call it to be a gap. That is what we studied. We said that when a wave is refracted, then what happens is that the amplitude and the frequency and the rest of other things remain the same. But we talked about diffraction. When the wave is refracted, its amplitude must change, its velocity must change, its frequency must remain the same. So he said it's the frequency and the period which remain the same when the wave is refracted, but velocity and speed has to change. I mean, velocity and wavelength have to change. So in refraction, what is important there is to note that when a wave is refracted, then its frequency remains the same, its period remains the same, but the velocity and the wavelength must change, together, of course, with the amplitude. But we also saw in diffraction, we said when a wave is diffracted, nothing is changed. The velocity remains the same, frequency remains the same, but only that the wave spreads. The wave will always spread to a bigger surfaces. So that's what we say. We discussed about refraction in water, where we talked about when water travels from deeper water, when a wave travels from deeper water to shallow water. Who can tell us what happens to its wavelength? If a wave travels from deeper water to shallow water, what happens? You can raise up the hand. If a wave travels from a deeper water to shallow water, what happens to its wavelength? Yes, David.
Yeah, sir.
Yes.
The wavelength reduces.
Very good. From deeper water to shallow water, the wavelength reduces. David, can you go ahead and you tell us about the velocity? What happens to the velocity?
The velocity also reduces.
The velocity also reduces. Very good, very good, very good, very good. So both the wavelength and velocity reduce. Good, good, good. So that is what we saw in the last lesson. Today, we are going to see the brother of all the two, which we saw last time. And the brother is what we call to be interference. We are going to discuss interference. Let me share my screen with you. Can you see on my screen? You can let me know in the chat whether you can see on my screen.
Yes.
Oh, good. So we are discussing interference. Can somebody raise up the hand and tell us about interference? Anything you know about interference? Anything which you know about interference? Good, I see some hands up. Let me pick. Let me check. The first hand is Daphne. Yes, Daphne.
Okay, sir. What I know about the interference of waves is that it occurs when two waves of the same frequency traveling along the same medium meet.
Oh my God, you know the correct thing, my dear. Interference,
Okay.
you know that when two waves having the same frequency and they are traveling along the same medium meet, you get interference. Let me hear from Anzoa. Anzoa.
Yes, teacher.
Can you go on and tell us about interference?
Interference is combining of two or more waves with the same frequency and amplitude to either form a smaller or a bigger wave.
Oh, good, good, good. Combination of two or more waves with similar amplitude and frequency, velocity, resulting into either a bigger wave or a smaller wave. I like that, Anzoa. Very good. Go to campus, Anzoa. Don't go to A level. Just go to campus direct. Oh, let me hear from Maria. Maria.
This is the overlapping of two identical waves traveling in the same direction to form a single wave with lower or greater amplitude.
I like the terms which you are using. I like the terms which you people are using. You're saying is the superposition. You are saying overlap. The other one is saying meeting. Oh my God. You people have physics terms for sure. You people have physics terms, I see. Superposition, overlap, meeting. Good. There's somebody with a hands up still. Let us hear from that person, Marvin. Marvin.
Interference is the effect produced when two identical waves traveling through the same medium in the same direction are superposed to one another.
Oh my God, very good. Superposition of two identical waves. So that is what interference is. You have defined it all. You are saying, or we are going to say, interference. Yes, it's the superposition. You don't want to use the word superposition. You say it's the meeting. You don't want to use the word meeting. You can say overlapping. You don't want to say overlapping. You can say over intersection. I don't know, intersecting. So it's the superposition. It's the meeting of two identical waves, of which those two waves must have the same frequency, must have the same amplitude, must have the same wavelength, must have the same velocity, and must be traveling in, same direction. Now, the effect of interference is that when these two waves meet, you'll either get completely no wave, zero wave, or you'll get the maximum wave. So we say that it results into a region of maximum and minimum intensities. Let me come again. Superposition is the superposition of two waves of the same frequency, same amplitude, same wavelength, same velocity, traveling in the same direction along the medium, it results into a region of maximum. When we talk of maximum, is the biggest, a region of big wave or a region of small wave. That is what we call to be interference. Is that okay?
Yes, teacher.
Hello? Is that
Yes,
okay?
Yes, teacher.
Yes, teacher.
Yes, teacher.
Oh, good.
Yes,
Good. Good.
Yes, teacher.
Yes. So this is the definition of interference. It's the effect that occurs when two waves of the same frequency, same speed, same wavelength, same amplitude, traveling in the same direction meet. Oh my God, I like this for sure. The effect that occurs when two waves of the same frequency, same amplitude, same wavelength, and same speed traveling in opposite direction meet. I told you, if you don't want to use the word meet, you can use the word superpose. You can use the word overlapping. Good, good, good. And which effect is that? It results into a region of maximum and minimum intensities. A region of higher velocity, higher wave, or a region of low wave. Good, good, good. There are two types of interference. Who can give it to us? Two types of interference. Who can give it to us? Who can give it to us? I see very many hands up. I like my class. This class is dangerous. This class is dangerous, I'm telling you. Annette Leah. Annette Leah. Annette Leah.
Master, are you hearing?
Yes.
Master, we have constructive interference and
Very
destructive
good. Very good. I wanted only one
interference.
Annette Leah. Annette Leah. Okay, let us hear from Lois. Lois?
Hello, sir.
Yes.
I give the two types of interference.
Yes, yes, yes.
Yeah, it's constructive interference and destructive interference.
Very good. You go to campus, okay, and study engineering. Is that okay?
Thank you, sir.
Kale, please. Okay. Thank you. So you're saying there are two types of interference. We have constructive interference and destructive interference. Mukama. Two types of interference, constructive interference and destructive interference. I see Claire in the chat. Claire says there's constructive interference and destructive interference. Now, who can help us to distinguish between the two? How do you differentiate between constructive interference and destructive interference? Maria, do you hear me?
Yes, yes.
Before you talk,
Constructive interference is the type of interference.
Maria?
Yes, teacher.
That's wait. I was saying, before you talk, okay?
Yes.
Allow me pass this communication. Members, for me to pick you, you have to raise up your hand. So don't say that, how is it that the teacher is not picking me? I like each and every one in this class. So you raise up your hand. When you raise up your hand, I'll be in position to see you and I pick you immediately. Yes, Maria, you can go on now. Maria?
Constructive interference is the type of interference where a crest of one wave meets another, forming a single wave with greater amplitude.
Oh my God, very good. I like the last statement. Forming a single wave with the greater amplitude. Wow. Maria?
Yes, teacher.
Can I ask you a question?
Yes.
What if a trough meets a trough? Is it still constructive?
Yes.
Oh my God, good. So you mean it's either a crest meeting a crest or a trough meeting a trough?
Yes, teacher.
Oh, very good. You can put your hands down now. I will want to give another chance for destructive interference to Singuzi Anthony. Yes, my brother.
Destructive interference is the type of interference which occurs when a crest of one wave falls on the trough of another wave,
resulting into
zero disturbance.
Very good, or zero displacement. A crest of one wave meets a trough of the other wave, resulting into zero displacement. I like that. So that means I can even use another word. I can say destructive interference is the type of interference where the crest of one wave meets a crest of the other wave, resulting into cancellation. The two waves cancel. Meanwhile, constructive interference is the type of interference where the crest of one wave meets a crest of the other wave, resulting into reinforcement. Now, I want to tell you something also little, of which I believe some people knew about it, but I see Duffin's hand has remained up for long. Duffin? Hello, Duffin? Hello, Duffin? Can you unmute, Duffin?
Yes, sir. So now what if I say that constructive interference, it occurs when two waves are superposed in the same phase, while
That is-
destructive interference occurs when the two waves are out of the phase.
That is what I was coming to tell you. Very good. You have spoken. Were you reading my mind for sure, Duffin? Duffin?
I don't know, sir.
How comes you're
No?
what I wanted to say for sure? Yeah, thank you so much. Okay, thank you. So we're saying that much as we're saying,
You're welcome, sir.
yes. When a crest, that's when you can mute. You can mute yourself now. When a crest meets a crest, we say those two waves are in phase. Then when a trough meets a crest, those two waves are out of phase. So you can see that for constructive interference to take place, a crest must meet a crest, or a trough must meet a trough. So when a trough meets a trough, or a crest meets a crest, then those two waves, we say they are in phase. Otherwise, if, like we say, a crest meeting a trough, those two waves are out of what? Phase, and so on. And so, for constructive interference to take place, the two waves must meet in phase. Oh my God, I like this. The two waves must meet in phase. And so what? Somebody is correct to say that constructive interference is the type of interference where two waves meet in phase, resulting into maximum intensity. Somebody is also free to say that destructive interference is the type of interference which occur when two waves meet out of phase, resulting into minimum intensity. Is that clear, members? Is that clear, members? Please let me.
Yes.
Yes, teacher.
Oh my God, good, thank you. Now, the two waves, these are the NBs, the conditions for interference to take place. Who can give us the condition now? At least we have gotten some idea about it. You can raise up your hand and you give us some of the conditions for interference to take place. I see some hands up. I see some hands up. There are people who have never talked for sure in my class. For sure, if you come in my class and you fail to talk, I doubt whether you'll ever talk in any class again. My class, Curable Jovial.
Shall I move in the same direction?
Very good. They have to be moving in the same direction. Very good. Let me hear from Trevor. Trevor? Trevor? Let me hear from Joel. Joel? Let me hear from Alvin.
When interference takes the same amplitude.
When they are traveling at the same speed.
Very good. The two waves must have the same speed. Let me hear from Alvin. Yes, Alvin.
When they are traveling at the same speed.
Very
That's the
good.
same point I mentioned.
Very good. Rachel, let me hear from Rachel.
The two waves must have the same wavelength.
The two waves must have the same wavelength. Very, very good. Modern says the two waves must have the same amplitude. Modern, you're very correct. Gaba, who is Gaba? Gaba, you can raise up your hand. I see you're saying no, teacher. What is that no? Gaba, you raise up your hand, I will see you. Let me first lower all the hands. Yes, Gaba, can you raise up your hand very fast? Gaba? I said Gaba, and everybody is raising up their hand. Yes, I've seen Gaba already. Yes, Gaba.
Teacher, I was asking that I didn't understand the definition. Because you asked, you understood when I didn't understand.
Okay, we were talking about interference, where you said that for interference, it is the superposition. It is the superposition of two waves. It's the superposition of two waves resulting into a region of maximum and minimum intensity. But those two waves must be traveling in the same direction, must have the same frequency, same amplitude, and the same wavelength. Is that okay? Or you can say it's the effect that occurs when a crest of one wave meets a crest or a trough meets a trough of the other wave, or a crest meets a trough. That is now when you come to the types, that is constructive and destructive. Okay, good. I see some hands still up. Excuse me, sir. My network has been disturbing. I haven't gotten the types of interference. That is Grace Ann. Musinguzi Anthony says they must be produced by coherent sources. I like the term coherent. When talking about coherent sources, yes, Musinguzi, Anthony?
Yes, sir. Yes.
Anthony, can you speak that statement which you have written in the chat?
They must be produced from coherent sources.
Very good. Can I ask you briefly, don't say that I'm disturbing. Can you briefly tell us, because some of us, we are hearing the word coherent for the first time. What do you mean by saying coherent sources?
These are sources that produce waves of the same wavelength and amplitude.
Same wavelength and amplitude. Okay, good. Then for those who do not know what a coherent source is, coherent sources, there are two sources. We cannot have a coherent source. We must have coherent sources. So these are two sources of sound which produce wave of the same frequency and what you call to be constant phase difference. Let me come again. These are sources which will always produce wave of the same frequency. The waves coming from these two sources must have the same frequency and constant phase difference. That's what we call to be a coherent or coherent sources. Good, good, good. I see some hands still up. Rachel, I picked you to talk and you did not talk. Rachel?
I did not hear the types of interference and their definition.
There are two types of interference. We have what we call to be constructive interference and destructive interference. Where we said constructive interference is the type of interference which occurs when a crest of one wave meets a crest of the other wave, or a trough of one wave, a trough of the other wave, resulting into maximum intensity. Is the type of interference which occurs when a crest of one wave meets a trough of the other wave, resulting into a region of minimum intensity. Is that okay, Rachel?
Yes.
Very good. So let's go to condition for interference to take place. One, the two waves must have the same frequency. We have already discussed this. The two waves must have the same speed. The two waves must have the same wavelength. The two waves must have the same amplitude. And lastly, the two waves must be traveling in the opposite, in the same direction. The two waves must be traveling in the same direction. If all of them are moving to the east, if one is moving to the east, another must also be moving to the east. West, west like that, something like that. Oh, good. So those are the conditions for interference to take place. Good. Then the types, we have already discussed them. We have two types of interference. One, we have constructive interference.
Excuse me, teacher.
Yes,
Excuse me, teacher.
yes, please.
Are you going to find the work in the Google Classroom?
Yes, yes, yes.
But some teachers promise us to put the work there and we don't find any.
Like which subject so that we can cross check and we put it
Biology.
Biology. So biology, we are going to
Busy.
put it there, okay? I'm going to contact the teacher and he puts the notes there, okay?
Okay.
But did you find for physics? Okay, good. So we are saying there are two types of interference, that is constructive interference and destructive interference. We have already discussed all these two types. We are saying for constructive, a crest must meet a crest, and a trough must also meet a trough, or the two waves must meet in phase. Then what about this is the definition? So we're saying this is a type of interference which occurs when a crest of one wave meets a crest of the other wave, or a trough of one wave meets a trough of the other. And I've captured all the two definitions. This is a type of interference which occurs when two waves meet in phase. When two waves meet in phase, these are supposed to be constructive interference. So this is the diagram that is trying to show constructive interference. So when we look at this diagram, this is a crest, a trough, A trough is adding up to a trough here. A trough will meet this trough, resulting into a bigger what? Resulting into a bigger trough. Then a crest here will meet the other crest, resulting into a bigger crest. That is constructive interference. Excuse me, teacher, why is your screen small? Hello, is my screen too small?
No, teacher, it's not.
Oh. Now, I will request Lois to put our phone on landscape so that at least you can see everything in full screen. Or make sure you pin my camera, pin me. You may find that you have not pinned me. You just tap on your screen where I am, then you pin me. You just tap, then you long press, then you pin me automatically. Okay, because others are saying Nara. Benjamin says Nara, Modern says no. So that means the screen is big enough. So constructive interference, that is constructive. Then we have what we're going to be destructive interference. For destructive interference, we already said a crest meets a trough. And two waves meet when they are out of phase. So we're saying this is a type of interference which occurs when a crest of one wave meets a crest of the other. Or type of interference which occurs when two waves meet out of phase, resulting into a region of minimum intensity, resulting into a region of minimum intensity. Oh, sorry, I'm seeing now. Okay, good, Lois, good. Now that you're seeing, it's very fine. Okay, so those are the two types of interference. When you see this diagram, it's trying to illustrate what happens. There's this trough, this is a trough, and then this is a crest. So when a trough meets a crest, then this one will be pushed back. Meanwhile, this one will also be pushed back. So eventually, you will see a straight line like this, cancellation, resulting into zero displacement or no displacement at all. So that is that. Now, that takes us to what we call to be sound waves. Who is a good Christian here? Can you raise up your hand if you're a good Christian? Don't lie to me. Who is a good Christian here? Raise up there. Oh, Benjamin. Benjamin?
Yes.
You're a good Christian?
Yes.
Carlos, we are going to prove this if you're a good Christian, okay? Do you hear me? Benjamin? Oh, Benjamin can't hear me well, I think.
Yes.
Can you hear me?
I'm hearing you.
Okay, so you have to prove your Christianity here. The question is, without seeing on my screen, okay?
Yes.
What is sound wave? Oh my God.
Not a true Christian.
Sorry? Let me hear from Patricia. Patricia.
Yes, please.
Hello, Patricia.
Yes, please.
Are you a good Christian?
Yeah, I'm a good Christian.
Are you sure?
Yeah, I'm a good Christian.
You prove it out from here now, okay? The question is very simple, okay?
Yes.
You got seeing on the teacher's screen, okay?
Yes.
What is sound wave?
Sound wave is a wave produced when
whether she's a good Christian. Go on.
sound wave is a wave produced when particles of the medium is set into vibration.
Oh! I want somebody to judge for me this for sure. I want somebody to judge for me this. Somebody who heard Patricia very well, please. Claire, did you hear Patricia very well?
Yes.
Is she a good Christian?
No.
Okay. Fine. I'm not here to judge you, Patricia, but you failed the instruction, I think, somewhere, somehow. So we are talking about sound wave. Now, when you talk about sound wave, before even you talk about sound wave, you need to talk about sound itself. Sound is a vibration. Is any mechanical vibration whose frequencies lie in the audible range. Or we are saying is a mechanical vibration. Is any vibration whose frequency lies in the audible range. We are going to see that there are some frequencies which cannot be heard. I'm talking and you're able to hear me because the rate at which the air molecules are vibrating is within the audible frequency. We're going to see ultrasonic frequency, which can be heard by only a bat. Even our human ears cannot hear it. So we're going to discuss some of those. So we're saying that sound is any vibration where the frequency of that vibration lies in the audible range. Then we have sound waves then. Sound waves are waves produced when particles of the same medium are set into vibration. Particles of the medium are set into vibration. So those are the definitions which we have to see here. Now let's go to properties of sound waves. I don't want to get somebody again. Who can give me some of the properties of sound waves? You can use the chat, you can raise up the hand. Properties of sound waves which you know. Kat is saying, teacher, we can't hear you clearly. Is that true, please?
Teacher, maybe it's her network.
It is our network.
Yeah, because
I'm very clear, right?
yes, teacher, you're clear. Maybe it's her network.
Okay, please.
Yeah.
Fine, thank you. Please first try to work on the network. You might find the problem is your network. Okay, we are talking about properties. Oh my God. Chirabo says they can be refracted. Lois says it is longitudinal. Very good, very good. Cannot travel in a vacuum. That is Albert, very good. Matter. You people have matter. Let me hear from who is this? David Murunji. Yes. Your network, David. Daphne?
Sir, okay, sir. properties of sound waves, yeah? It is caused by a body in a vibrating motion.
Very good. It is produced by vibration. Good, good, good. Patricia? Patricia?
Waves can cause
They cannot travel in a vacuum.
They cannot travel in a vacuum. Good, good, good. Patricia, should I ask you another question? Patricia?
Yes, please.
If they cannot travel in a vacuum, what is the mechanism of transport of sound?
Pardon.
What is the mechanism of transfer of sound? What does it require for its transport?
I don't know.
It's okay. Who can give us the mechanism of transport? What does sound wave require for its transport? You can give me on the chat also.
Material medium.
Yes, Daphne. Yes, Daphne.
Sir, I wanted you to pardon for me the question so that I can answer.
What is the medium of transfer of sound? What does sound require for it to move?
Okay, Master, okay, I'm trying.
Yes.
I sound, it requires to travel through solids, liquids, and gases.
Okay, solid, liquids, and gases. Okay, good. Now, I see chat people are saying through material medium. Which material medium here is what I want? What's the material medium here? Okay. Someone's up. Modern. Modern, can you unmute? Yeah.
Sound requires a material medium to travel.
Which material medium in this case? Oh, sound requires, let me hear from Alvin before I give the answer. Alvin?
Yeah, thanks. On my side, I think that it would be the solids.
Solid, okay. Okay, then lastly, let me give to Anthony Musinguzi.
I think the material medium is matter, like solids, gases, and liquids.
Okay, now let me give you the material medium. Let me go to the chat before there's nobody in the chat, but the material medium for the transfer of sound is air. Let me come again. The material medium for transfer of sound is air. Without air, you can never hear your friend. Air must be vibrating. Air molecules have to vibrate for sound to be produced. Is that clear, members? Hello, members. Is that clear?
Yes, teacher.
Yes.
Very good. Very good. So the mechanism, the material medium required by sound wave to travel is what? Is air molecules. Good. Let's see. We have already discussed the properties. We said that sound waves, one, cannot travel in a vacuum. Two, it is longitudinal. Three, can be reflected, refracted, diffracted, and undergo interference. Four, it is produced by vibration of particles of the medium. So those are the properties which we have just discussed. Now, I see some hands up. Before I go on, Let me pick them. Yes, Alvin. Alvin. Pace chatting. Pace. Yes, Pace.
Teacher, don't they possess energy?
They do, just like all other waves. The air molecules which are vibrating are the ones which are possessing the energy, not the sound itself. Okay. Oh, good. Daphne, you have a question?
Yeah. Now, what if I say that sound waves have a frequency ranging between 20 hertz and 1 hertz? Is that a property of?
Oh, now when you talk of frequencies, we have very many frequencies, and we're talking about sound waves. When talking about sound waves, should be within the audible range, okay? But that is just audible range. That's the audible range which you have just given to us, but cannot be one of the what properties. Is that okay, Daphne? Okay, good. So let's see an experiment to show that sound really requires material medium for its transfer. This is an experiment to show that sound requires material medium for its transfer. Let me first take you through this video, then we come back to that. Are you able to see on my screen?
Yes.
Okay.
Yes. Yes, teacher.
We are going to do this. Let's do this. Let's watch this video.
We can see your screen, teacher.
Are you able to see that video?
Yeah.
Okay, let's watch.
Yes.
Teacher.
There's no sound.
Teacher, the volume is low.
Volume is not there.
Let me try to increase on the volume.
Yes.
The video is
not
deleted.
steady.
The video has deleted.
The volume that is maximum.
But sorry, I'm not hearing anything.
Do you hear the sound?
No.
No.
Not getting any sound.
You're not getting any sound.
Yes.
Teacher, we are not hearing.
No? No?
We can't hear anything.
Okay.
Yes.
I'll send the link only. I'm going to send the link to that video, and then you watch it direct. But the issue is, okay?
Okay, sir.
The issue is,
Okay.
what we do, we put the electric bell. Are you seeing on my screen? Do you see my screen?
Yes, sir.
This is a bell jar. So you put electric bell in a bell jar, okay?
Yes.
Then the lower part of the bell jar is connected to a vacuum pump. The use of the vacuum pump is to remove the air from the bell from the bell jar, okay? So when you switch on the electric bell, the hammer, which is this, will strike on the what? The hammer, which is this one, will strike on the gong. And you will hear the what? You will hear the sound, okay? Then from there, when you remove, using the vacuum pump, you start removing the air molecules slowly by slowly from the bell jar. As you remove, the sound produced by the bell jar, by the electric bell, will start fading away slowly by slowly. Do you hear that?
Yes.
The sound will start fading away slowly by slowly. And then when all air molecules are removed, okay, then there will be no any sound heard. Even when the gong is seen, when the hammer is seen hitting the gong. Do you get that?
Yeah.
So now, from there, again with the help of the vacuum pump, you bring back the air molecules slowly by slowly. Is it okay?
Yes.
It is going to be seen that the sound in the electric bell comes back again. Do you hear that?
Yes.
So,
Yes, so
here you make the conclusion. Is that fine?
yes, sir.
Thank you so much. We are going to send, I will send the work on our Google Classroom. Is that okay?
Okay,
Yes.
sir.
Send the work in the Google Classroom. I thank you for attending. May you please have a nice day and a nice weekend.
Thank you, sir, for teaching.
Likewise, teacher.
Have a nice weekend.
Goodbye for now.
Have a blessed day.
Bye.
Next time. Excuse me.
Bye.